day and welcome. I'll start now and let's talk a little bit about Qt and embedded systems. First of all, let me introduce myself. My name is Claude. I've been working with Qt and Linux actually for a very long time now. It's been 13, 14 years now in total. Started basically working on that through the KDE project in 1997 around. And did some work there, first on different things, but also my main work there was the HTML engine, which I started, which later on turned into WebKit. And then I've been working with Qt since 2000 as a professional software developer, working in different areas there, leading in times the development team that was in Fortran and in Nokia, and now working as the Qt sheet maintainer for Digia and the Qt project. And I do live in Norway with my family. So let me just start off firstly, slowly introduce a little bit Qt for those of you who don't know it. Let's keep it short. I would assume that most of you haven't heard of it before. It's an application development framework cross-platform. Qt works on Linux, Windows, Mac. QNX lately has become a very strong player who's using that as one of their standard frameworks now, the next version of their platform. And so it contains a comprehensive set of C++ libraries, pretty much everything you need as an application developer. A UI language called QML, I'll come back to that later, which makes it very easy to create smooth and animated user interfaces. High quality APIs, documentation, and a full-fledged IDE around the whole thing. It's now, since 1 year, being developed as an open source project on qtproject.org. Qt itself has always been open source, since the very early days. First under, some not fully open source compliant license, later on the QPL, GPL, and nowadays LGPL. And we have a very strong community out there on the Qt project, working on improving Qt and bringing it forward. As currently, if you look at it around, we're live now since 1 year, and over the last year, I think we had around 27,000 commits going in to Qt, which is sizable for an open source project. Qt uses a dual licensing scheme, so we have Qt available under the LGPL, GPL v3 as well, actually, and the commercial license, which is used then, which is sold by Digia, which I've been also working for, and the commercial revenue is then used also to fund the further development of Qt as a project. Start off a little bit, when we go now into what's Qt and embedded. Let's go a little bit back to the early years. Actually, Qt started off on Windows and X11. And what we did there is we used native API for everything. All the painting was actually done by the windowing system. So GDI on Windows, XLib on X11. And every widget that you see in here is a native widget. So that's a screenshot actually from painting 1 time. Some of you might have seen that before. It's not really sharp here, but you see lots of things in there, and every control was a native window of the underlying windowing system. That used to change later on. And then, around 99 times, embedded systems on Linux actually became relatively interesting. On high-end embedded systems, you had a 240 x 330 screen, you had 16 megabytes of RAM and so on. And faster processes and a little bit of hardware acceleration for some 2D graphics. So Linux became an interesting option, and many companies were starting to look into Linux for their embedded systems instead of many of the proprietary systems. But there was no real UI solution available. And X11 was just too big for the kind of footprint and flash space you had available at that time. So we had a prototype actually at that point, which was something, software rasterizer called Qt Paint device, which drew 2D graphics into a raster buffer, and then we thought concatenated it as a frame buffer. Seems to fit together, and we actually started the project called Qt Embedded and the Qt Windowing System, QWS. Started in 1999, we wanted to keep things lean and simple, and we managed to make it to run on 8 megabytes or less of RAM and ROM. Less would be difficult, but it still worked. Interestingly, Interestingly enough, the choice that was made at that point in time was to build the windowing system into the framework. So we extended the whole framework. The Lighthouse was a piece that was actually the windowing system. Then any application could be the server process, the window manager. Just was a matter of specifying a special command line flag. It was available, with single process and multi-process modes. And what was there out of the box was software drawing into the Linux framework. So what you see here is an example of that, one of the earliest screenshots where we got stuff working. See the Linux frame buffer, and then on top of it, we do a window with the Qt application. And actually, we were pretty good at that point in time. We got a minimal stack to pick on the 1.4-inch floppy, which was interesting, at that time, for distributing at events like conferences to just hand out these floppies to everybody. And people could boot from them. I guess that time's over by now. What we soon realized was also that just having that framework available wasn't enough. People wanted to see more. And we actually created something called the Qt Counter environment at that point in time in Trolltech, which was the company behind Qt. And created some demo apps for that. You can see some screenshots here of these apps, the application grid. It doesn't look too different from what we have nowadays on our smartphones, actually. And calendar and all these things were there, but they were pure demo apps. And a little while later, we rebranded that as a tutorial environment. Interestingly enough, we got a big customer buying that one. That was Sharp for the Zorus. And we went from that demo to shipping in 6 months' time. It was a pretty crazy time at that time. I was working day and night trying to get that stuff out. We managed in the end and shipped the Zorus, and it was actually pretty successful, especially in Japan. That was Utopia. At the same time, we started going over and moving into industrial embedded, where all possible combinations of the stacks were being used. We started off, some people used the minimal configuration, where we just had, the Qt drives down to 700 kilobytes, and you have almost nothing. All you got was a drawing surface you could draw into, use that, and do some 2D graphics. People did that, for example, for some oscilloscopes where they showed, the waves and stuff like that with it. And some others went all the way to have the full load Utopia stack up and running on these devices. So that was all happening in Qt 2 times. Qt 2.3 was the main version for that one. But then meanwhile, something happened in desktop land. We were basically, as a company, generating most of the revenue that was actually used also at that point in time to fund the development on, customers working on the Windows, especially Windows, but also the Linux desktop. And we, had a big pressure to add lots of features for them. So in 2002, we shipped Qt 3, added lots of these things, but, one of the things we forgot was the embedded side. Qt got really fat, got a big framework, and it got way too slow for many of the embedded customers we had at that time. They had no chance of upgrading to Qt 3. And we ended up with a situation where we had to support Qt 2 for the desktop customers for a very long time, actually throughout the whole lifetime of Qt 3. Which actually led us to, moving, after 3 years' time towards the Qt 4 release. We started around working on it in early 2004, I think. And that brought back most of the speed that was required for embedded devices. We had learned from our mistakes there. And we, added new functionality that made it really interesting again. Some of the things we learned also was that we migrated some of the things that we had seen on the desktop, on the embedded devices that we used there back into the desktop version. One of the problems we had, for example, on the desktop, this thing that every widget that we had, every button was its own native object in the windowing system. It was a big mistake. It made many things very slow. It made it really difficult, for example, on the desktop to do smooth resizing of windows, one of the things that people really wanted at that point in time. We then implemented a feature called alien widgets. Something that's very standard nowadays is that, the windowing system is just giving you a top-level surface. You draw into that one, and everything else is taken by the frameworks. That was pretty new at that point in time. And we also added the shaping abstraction there for the paint engine. said, we were using the underlying XLib calls very much. We still had a paint engine that did that, but we also added different ones. So we had one that could then draw into a software buffer, and the raster buffer that was also used for the embedded version by default. We had one that could draw using OpenGL. We had one that could generate PDF. Things, that I think probably later on also inspired projects such as Cairo. And all of that, was good and fine, but then, we had that version, but, around 2006, 2007, we had, customers coming up, with designs for voice over IP phones. We were doing ourselves a, mobile phone, actually, the green phone in Fortec, used for the Qtopia, so where Qtopia pushed that to be a full, phone stack. And what we were seeing there is that we wanted to have fluid animations, things like that. So you see the selection grid in the phone. When you move from one to the other, we wanted that to move smoothly and be slightly animated so that the icon gets bigger. And the VoIP phone had lots of demands, for having transitions and these kind of things. So it was still a little bit pre-iPhone, but these things were starting to turn up in the industry. We got a lot of demands for that. And what we found out is that, our existing model using widgets, rectangular items you could draw into it, wasn't really cutting it. We couldn't do these things with the framework that we had in place. At the same time, another thing happened. We got, bought by Nokia. The whole, Trolltech, the company that was developing Qt, got bought by Nokia, and that meant actually a full shift from desktop development to embedded development. Not only Linux embedded, but also Symbian as one of the main platforms. And we got huge amounts of requirements there, upping the performance. I mean, things were too slow in all different corners, where we were doing a lot of work there, and Nokia actually also added a huge investment there in terms of, the framework development, but also on the tooling side. We created the Qt Creator IDE during these years. We added lots of APIs for mobile use cases, the mobility APIs. But not only that, also multimedia was part of that, sensor integration, all of these things. And one thing that Nokia also did that Fortec would have never been able to do is what we went LGPL. Because for Nokia that was, a doable thing. They had the money behind, and the motivation, the revenue was supposed to come from somewhere else. Since over the years, I mean, in the end, we managed to ship the Engineer 9. It took a long time though with my Mobido, but that's a completely different story, and I won't go into that one today. We, used Qt quite a lot on the Symbian free phones. You see there the OB store, that's a Qt-based application. And we did a lot of work. And while we were there also, as I said, we had these big demands from customers, the VoIP phones, the mobile phones, and we saw the limits of the Qt architecture. The widgets we had were rectangular items, and animations were pretty impossible. You wanted to have smooth transitions where you moved them out of one place in the hierarchy into another place. It was impossible to do with fixed, strict hierarchy. And we had no way to realize the UI designs in a clean way. We tried for one customer to do that and put it together using all the C++ code. It was a big mess, and we were seeing that we couldn't do this another time. So we started some research projects, actually two, one in Oslo and one started in Brisbane. That was two of the offices we had. Oslo was doing mainly the Qt frameworks. Brisbane was doing the phone stack on top of it for Qtopia. And we had a scene lab called Qt Graphics at that point in time. We still have it actually. And we said, okay, and also we said that's probably a good basis. We want to add animations, states and positions to it, and some, maybe some added sugar on top of C++ to make it a bit easier. But mainly try to do a C++ framework that allowed us to do these things. Brisbane took a more radical approach, and it was called QML at that time, and the technology is still called QML these days, or the language, which tells you also a little bit about who had, in the end, a better idea. They went for a new XML-based language actually to implement this. And we're really asking the question, I mean, for UI design, when you do user interfaces, smooth animated user interface, do you really want to do this in C++? And do we maybe want a different scene graph to do this? Because what we had in Qt was drawing imperatively, through function calls. That's not how graphics hardware works, and that was a realization. But in the end, we then, had a Qt quick, version where we took most of these ideas from Wisdom, but we changed XML to its own language, which is an extension actually to JavaScript, even though it might not work that way. You don't see any JavaScript here in that example I have here. That's a simple Hello World application in QML. You have a rectangle with a certain width and height, and you have text in there. And just to give you some example here, I can add the binding. So what we say, first of all, we say that the text item is centered in the parent item. That's a property binding. But the parent item would change its size. I mean, the centering would be, would stay. Just added the text, and then we have something here where we set the color to the text color of the parent. And the interesting thing is now, if you would change this text color, this one here would automatically get updated, and the rendering would get updated. It was an interesting, very interesting approach, and we found that it's a fantastic thing then to do user interfaces. It's a fully declarative approach where you really bind properties of your user interface to expressions, and these expressions could be arbitrary JavaScript expressions. Now, if you make them too complex, I mean, things tend to get slow. But apart from that, it works beautifully. And that was what then made up the QML language. It's Java, so it's JavaScript-based. It has object trees used for rendering, and a declarative syntax with property bindings. And we from the very beginning wanted to optimize this fully for UI design. Make it possible also for graphical designers to understand the language and be able to use it. And that's what we do with language. It has a very small C++ API, but it is easy to bind to and extend things from C++. You can expose objects from C++ into QML and then bind to them and do things with them. So you could easily bridge two worlds. Another thing we was doing there at that point in time was the Symbian port. And the Symbian port really showed that the way we did the Windows system integration was flawed in Qt at that point in time. We had, basically files, and we were doing it in the separation file base. So we had a QWidget file which implemented the widget class, and then we had _x11, _win, and so on files implementing the platform-specific parts. Now, what would usually happen was that you took the _x11 files, copied and pasted them for the new port, and then threw out all the x11 calls and started from there. And it led to a huge amount of code duplication, and it took very long. It was very hard to do. QWS, the Qt windowing system, was also reaching its limits. It was perfect and very good in the 90s, was limited to the acceleration. But integrating OpenGL or OpenVG, at that point OpenVG was also interesting to some people. It was very hard to do. And we also saw that porting to other operating systems was very challenging. We had some people who wanted to have to work on VNFDX works or QNX. And the hardware adaptation was really, really difficult if you wanted to have this optimized. I mean, getting it running with pure software on the frame buffer was a breeze, worked out of the box pretty much. But then, having the hardware acceleration, you have two options. You could write a complete code of Qt, that was around 50,000 lines of code, or you could hack the Qt embedded port, which, because of its difficulties, was in the end probably less lines of code, but not less work. And both were very error prone. It was really difficult to get a good port there. So we went in, did a project called Project Lighthouse, where we tried to do a clean API, the Qt platform abstraction layer, to encapsulate the windowing system and the integration with the underlying windowing system. That was released actually last year with Qt 4.8. And what had happened then was that we immediately got Android and iOS ports done by third parties. That actually proved the design was right, because the ports happened without, it was usually one person behind it, and they managed to get a relatively complete port of Qt to these platforms done on their own. We had also a backend using EGL and OpenGL, which runs as a full screen mode, so one surface only, done with around 2,000 lines of code. And hardware acceleration worked out of the box, provided you had some drivers that supported it. The difference there to the old Qt embedded version was that we do not have our own windowing system anymore. So there was a question how we support that, and fortunately on Linux the project came up and actually came to the rescue. That was Wayland. Wayland was working on providing a new windowing system that should hopefully in the long term will replace also X11. And that was exactly the thing we needed there. Because we didn't want to replicate the server and the window system pieces, the window manager pieces in Qt. So having all these things and seeing that there were lots of changes in the world underneath us, having touch-based user interfaces, fluid animations were becoming really, really important and a must-have on many sites. Also, we saw that happening more and more on these embedded devices, that people were asking for touch screens there and how do I get a really nice user interface there. And many of the other reasons. So we decided at some point then now to go for a new major version of Qt, where we used some changes. First change we did was we based it completely on the Qt platform abstraction layer. So also the desktop tools, Windows, Mac, then the X11 version are based on that one, everything. Second one, we went and changed the Qt quick QML thing that I showed you a little bit earlier. I'll show you some demos a little later, to be OpenGL based and use an OpenGL based C graph underneath it. Use threading, a set of rendering threads, so think the main thread will block the UI, and really aim for having fluid and stable 60 frames per second user interfaces. We also separated in Qt Core, Qt Quick and the Qt widgets were still, entangled, and we separated that now. So that on many embedded devices you can get to a much leaner stack, because the Qt widgets is often something you don't need there. And most of these ideas from embedded have now entered the mainline Qt version and all the Qt tools. I think Qt in general has benefited a lot from that. Also, the desktop versions are now much easier to maintain and actually I think provide also a lot better performance. We're working on this now, and we're expecting that we'll have the beta 2 out within a week or two from now. I'm always a little bit optimistic, but I think it's pretty reachable right now. And we want to have the final ideally before Christmas, so we can all enjoy Christmas. But let's see, if not, it will be January. So let's go over to what kind of options do we have for Linux now to write, to do embedded or to do devices, to use things. We have actually what found out is that there are lots of backends for this Qt platform abstraction that came into existence that different people wrote. Started off, one of them, the first one that we got was for DirectFB. Some building acceleration, input handling is going through standard UDEP input. That was the first contribution, the fourth contribution to the Qt project. It was one of the first contributions we actually got after the Qt project went live a little bit more than a year ago. And you can do OpenGL there as well with some vendor integration. The whole backend is around 3,000 lines of code. The next one we looked into was XCB. So as we didn't want to go to Xlib anymore, so we went one level lower to XCB to do the X11 version. That one is around 18,000 lines of code. And now you see that it's quite a bit bigger. And the reason for that is that on the desktop you need many more things than you need on many embedded devices. We have drag and drop and clipboard integration that we need to do. And that is a pain on X11, unfortunately, which is probably around a third of the things in itself only. And many other things. But if you compare that to what we had in Qt 4, where the X11 support and all the code base that was XML specific was around 50,000 lines of code. You see that we still managed to reduce it by around 2/3, which is very, very good. We have some minimal backends which basically are there to help you get started. They don't really do anything. Minimal, you can just render into a PNG file. It's not very useful, but it's a good starting point if you do your own work there. And we have some experimental plugins. KMS doing, using the kernel mode setting and UDEF a little bit to do some basic things. OpenWF, the Cronus window system or window manager API, Linux frame buffer. They're all very experimental, and we have two that are really, I would like to present a little bit in more detail. It's called EGLFS and Wayland. So the EGLFS backend is actually, FS stands here for full screen, so it's the EGL full screen backend. It creates one single surface, full screen surface to EGL, and then uses OpenGL, or you can also use software rasterization for drawing into that surface. Directly reads from the input devices, so it uses UDEF to do the device discovery, find out what kind of keyboards, mouses, touch inputs you haven't touched, integrates with that. It's single process only, so only one process can at any given time get to the screen and get the input. But on the other hand, it's very easy to integrate. So it's around 2,000 lines of code, and it's really a great option if you only want to have one UI process running on your device, and if you have EGL and OpenGL available. I mean, one process doesn't mean you're limited to just single things. I mean, in that full screen surface, you can do anything you want, and you can also there create things that look like pop-ups and that behave like pop-ups, but it's just done in one rendering surface. The other one we were working a lot on was Wayland. And I don't know how many of you have followed the process of progress of the Wayland project, but it just released. Wayland 1.0 was released a week ago, I think. Is it 2 weeks? 2 weeks ago. And we now have we've been working on that all the way along the development process, following it, also helping out in developing the Wayland module, giving our feedback on where things needed to change, contributing many touches there. And we now have a fully functional, we now have something that works with Wayland 1.0, 2 weeks after it's been released. And there were quite a few API changes, I think, on the last minute that, so one of our guys sat down now last week and got it all working. That's really very fresh. And the Qt plugin that we have with Wayland, it's around 7,000 lines of code, but it's really fully functional. It has clipboard support, drag and drop, can handle all the different inputs, touch input, mouse, keyboard. I think, is there now an integration for input methods? I'm not quite sure. It's coming, so once it comes, we'll support it. At the same time, we also developed what we call the Qt Compositor API. And that's something that builds on top of Wayland as the server component. So it allows you to create your own Wayland compositor. And it makes it very simple, to manage services from the different applications. You have an integration into Qt Quick or QML, the language that I showed you earlier. And you could write your compositor mostly even in that QML language. Make cool things about it. What's good about it is it's compatible with all the other frameworks that will also, be supporting Wayland in the future. GTK, EFL, and whatever else there is out there. So you can mix clients between the different toolkits if you so need. And you could also use any other Wayland server. So that's probably the best solution you can use if you want a multi-process environment and you need to integrate with other frameworks at this point in time. There's also, I talked a little bit to the Yocto guys, and there's a strong interest there to get this Qt integrated there as sort of a pre-packaged solution so that everybody can use that and add it in a very easy way. So now, let's get a little bit of demos and not try talking. have a Raspberry Pi with me, and I'll try to see if I can get something working there. So you see the Raspberry Pi is a small device here like that, being sold for around $35, I think. So it's a pretty cheap device, but it can do full HD output, and let's see if we can get something running here. I might need to reboot the device actually. Let's see. There it comes up. Yeah, if there's any questions in the meantime, while this boots, no, it's there already. Let me go down. Okay. So one of the examples here that's using Qt. This one's fully implemented in QML. There's no real native code done behind it. And it's basically a moving earth. Let's see if I have a mouse here somewhere. Oh, it's cutting off some parts. I can do certain things, changing, one of the things, hit the thing. So you see here's a little bit, oh, that's too small. It's optimized for full HD, so it doesn't really work. You can do motion blur, wobble, and this is just a small thing, and small demo application. Another one that I can show is the same game. This one's actually done for a smaller screen, so it should look a bit better. And you can do a simple thing here where you can then do exploding bubbles, and you see that you can do lots of effects here, and all of that runs really full, smoothly at the 60 frames per second, which you have. Back to the menu. And these things are actually implemented without any QML. So let's see now if I can get something with you. And these things we're using the EGLFS backend. Let's see if I can get the Wayland demo running. I had some trouble with that lately. Switch over to the presentation again. So we were here. Next one. Then some questions that some of you might ask. What am I doing if I don't have OpenGL in my hardware? Right now, what it means is that Qt will work nicely, but you will not get the Qt 2 things that I have just shown you. But you can still use Qt quite a bit. There's some options to use Mesa and the LLVM and LLVM together to get software OpenGL and a good performance working. That will allow Qt to work nicely. Qt 2 at least. Qt 1 will always work. But it's right now, I know it works nicely on x86. It's untested on ARM, and what I read up on the ARM LLVM mailing list, there's a chance it will work with LLVM newer than 3.1, but as I said, it's untested right now. So we'll have to do some work there to see how that works. And the plugins you can use either Wayland if you have a multi-process environment. It will then not use hardware GPU textures or frame buffer objects with that, but shared memory buffers. The direct FB, Linux FB backends should be working, and XCB if you want X11, it's also working with secure software. So let's move a little bit over to what we're planning now to do in the future. As I said, we have a wide variety of backends existing today. We have the Mac, Windows, we have QNX, BlackBerry 10 in addition to the Linux ones I already presented. And it's very easy to get started on new hardware or even a new operating system. One of the first things we're now going to do is extend Qt to be more cross-platform, add Android, iOS, and I think for you guys here, probably Android is the more interesting one. And we'll do one other thing, a few other things. We'll add some components, quick components for touch. So what you've seen right now in the demos, I mean, you saw in the same game demo a button somewhere and these kind of things. These are usually all done right now by hand. Qt Quick by itself mainly supports primitives, rectangles, text, some input, some clickable items where you can flick a flick list, some other things, but we want to extend that a little bit and have a full set of UI components available that are optimized for touch interfaces. We'll also have a second version of UI for mouse input, UI elements. But that's really there to simplify and make lives easier for anybody who wants to create user interfaces. Then we'll have strong focus on the embedded use cases and requirements. So, one of the things that's there is really the tooling actually. As I said, we have an IDE, you can create an IDE. What we want to do there is really do better support for cross-compiling, remote debugging. We want to look at how to make deployment and flashing of the devices easier and all these things, and see what we can add into there. And any suggestions that we also have there, anything you really need, would be very welcome. I mean, I'd also like to invite anybody who really has an interest there to join us on the Qt project and really work with us on these things. But by the way, the device we see here is one of the really new ones. It's an actual medical device doing wound imaging. So it does really a three-dimensional picture of a wound and then processes that and gives the doctors advice on how to best treat these things. Pretty interesting. So going to Android, what are we going to do there? We're actually going to do two things. And that's what we're going to do. One of them is an Android port. So basically, port Qt, there's an existing port for 4.8, as I've told you a little bit earlier, called the Lighthouse project. We want to bring it to Qt 5, and that's really there to fully integrate with the Android stack. Make it possible to, to really write Qt apps and deploy them to the Android marketplace. We want to offer a native runtime that actually, manages to keep compatibility between Android versions. That's our goal. And have a deployment solution in there so that you can easily package your app, things up, your app up, bring it to the marketplace, send it up, and it will also, that deployment solution will then also download the necessary required Qt frameworks for you on the fly. The second option that we're looking into is embedded on Android, as I call it. It's a work in progress name, and we haven't really started with these things yet. Just some very early things. What we want to do is use only the Android base layer. And what we're seeing is that many of the chipset manufacturers have provided, especially on the outside, usually an Android adaptation. So you get an Android kernel plus the GL integration of working on Android, all the other things. They all work on Android, and that's what they do. You do not get this offer for standard Linux, unfortunately. And so we thought maybe we can just use that base layer, put Qt on top of it, and then have maybe Dalvik available, but as an optional thing, you don't need it. You could just use Qt to create your user interfaces, your application, and create your device, embedded device with that. So we're just starting the work, and there's lots of open questions about how to implement these things in detail. We don't know yet. Looking into that. To illustrate that a little bit, that's the Android port. Many of you might recognize that picture. It's a standard Android, how the Android stack looks like. get access to many of the things like the sensors and many other things where we need that, but also use some of the native things for OpenGL, for example. And then you can write Qt applications just as a regular Android application. The other option is then this one here, where we really want to make the Android runtime Dalvik and most of the frameworks optional. They still can have a value. Sometimes they do, for example, some of these pieces of policy management, like audio policies and these things. So they're there, but if you don't need them, you can probably, we will try to make them optional so you can remove them, put the Qt there, have a very lean stack, and write your applications with that. So as a last thing, I have a demo here, but the problem is I don't have a projector for it, so I can only show it that way. That's actually Qt 5 running on the Nexus, where we did exactly that. We basically replaced the whole user interface. It's called and you see we can add some effects here and stuff like that. So it replaces replace the surface flinger with just starting our own Qt app and have that running here, and it's running smoothly at 60 frames per second on this device. So whoever has an interest in that, just come to me after the presentation. I can show it a little bit. And that's the start of the work. We just started and we'll hope to have some more there in the next half a year. And with that, I think I'd like to thank you. Just one hint here. Don't miss Jan's presentation on Qt project and Qt 5 tomorrow afternoon if you're interested in hearing more about Qt and especially the Qt project. Thank you very much.
If you say you want to provide richer set of components for Qt Quick 2, okay.
Hello? Just look up.
Okay. So if you say you want to create a richer set of components for Qt Quick 2, will you at least kind of reuse some stuff that Intel and Nokia did with their components, or?
Yes, absolutely.
Okay.
We have these components that Intel and Nokia did together for MeeGo. We have the things that Nokia did for Symbian. And fortunately, we can reuse them without any problems. So yes, we're doing that, but we're also looking into how we can. So the API will be relatively compatible, I would say. We will extend them, and we want to really make sure that we have some of them really optimized for the touch interfaces.
Okay.
Probably, go and have our own look and feel, because we can't really reuse easily the look and feel. That is what's happening.
But
we can't reuse, for example, the look and feel of the N9.
Yes, of course. But you will ease the porting pain if you want.
That's the goal. Yes.
Okay.
I mean, the whole goal with Qt 4 to Qt 5 has been, and I haven't mentioned that explicitly, is to make porting as easy as possible. So we try to keep source compatibility as much as we possibly could. We have changed very few things, and I mean, we have now Qt Creator running, against Qt 4 and Qt 5 with the same code base. And I think, just a handful of if-ifs in the whole code base. So that tells you, it's a big project, and it tells you that it's possible. And the same thing actually is what we also aim for on the new Qt Quick side. 6. Okay.
I have a question about a maybe common use case. When you have a standalone embedded device with an LCD running Qt, let's say the QWS system, and now not everybody in their pocket has a tablet or a smartphone, and the client says, oh, I want to be able to control the UI from my whatever phone or tablet. And I looked, I admit, not really deeply, and the BNC support in the old QVS is just for debugging, so it's either or, either on the LCD or in the built-in VNC server. And running some external VNC server on the frame buffer brings additional problems, because usually the touchscreen is not using the normal input subsystem, but BTS, let's say, so you miss the input. And do you have any idea of the best solution for this to expose the UI?
We need to go into the details of what you really want to achieve. I mean, if you want to get the Qt app on the tablet, I mean, that's where the Android and iOS ports might become very interesting for you, because you can then deploy the same thing. I mean, Is that what you're really looking for?
No, my question is about the app is running on the device, whatever it is, just to a remote access to the UI, not to run the app on the tablet or phone. Like, for example, I think the GTK project has something like writing to the new HTML5 canvas element, so you can access the app using any device.
Yeah. No, we haven't gotten a solution there right now, but it's something we've been talking about internally. I've been talking with many people about it. It is very interesting, but I don't have a solution right now. I mean, a VNC also backend might be also an interesting thing for QPA, which would also allow some of these things.
I have experimented a bit with classic Qt4 and QML surface technologies on rather low-end ARM hardware like 400 megahertz and some tens megabytes of RAM. And I noticed that especially the startup of the QML interface is considerably slower, and I also noticed this delay when you fired it up on the Raspberry Pi. So my question is there some way to pre-compile that or speed it up for embedded users?
There's two things. Right now, the current existing solution is to basically in QML use the loader element, which allows you to delay loading of certain parts of the UI until a later point in time. So you load basically just the initial screen, get it up, and with that, I've seen Qt on a, let's say, 600 megahertz device. I've seen Qt apps, also relatively complex Qt apps, starting up in around a second with that, but it requires work. Now, in the longer term, what we're looking at, and I've started looking into a project where we actually look into how to compile QML into native code. That's work in progress. Let's see when we'll be done. Not before, probably not before the summer.
Thanks.
If we have it for the summer, I'd be extremely happy. Let's put it this way. I don't. Probably takes longer.
So it looks to me like widgets and QML are completely different universes. You have widgets that you create a button and it's all styled good. You have QML when you have to build it from pixels. Is there any plan to be able to take existing widget-based code and create QML scene graph from that, and then animate it as I wish?
Not directly. We do have some plans right now to make the integration easier between the two. Because as you said, right now it's two separate worlds in a way. What we want to allow is to allow that you embed QML inside a widget hierarchy, and maybe also the other way around. What I don't want to do is start doing the mistake we did when we did graphics, which allow arbitrary transformation, for example, of these widgets. That's just completely very, very painful, and basically will destroy the whole. Will make things unmaintainable externally. So what we possibly can do is make sure that we can embed widgets, in a rectangular area, but then only non-rotated and not scaled. But that's for most use cases probably enough. So that's something we've been looking into, but hopefully. Any more questions?
So this may be a bit specific, but I have applications written using JavaScript and running in a web space, and I would like to experiment with running in QML to get better hardware acceleration. Currently I can't do that because the QML JavaScript engine won't allow standard JavaScript libraries to run in there. I have to rewrite an awful lot of the business logic of my application. So things like the global objects of JavaScript is immutable in QML. Are there any plans to change this?
The global object inside in JavaScript code is fine. So you can have .js files, right, and then include them. And the global object is fine. You can change it. It's in QML mode. It's immutable. But what you do not have is the full DOM that you have on the web.
That's fine. I'm happy with not having a DOM. So the experiment we're trying to run is to take an application that's written around Backbone So an awful lot of the application logic is already in JavaScript, but replaced the view layers with QML objects. We're finding it possible because of the JavaScript engine, even though it's an underlying VF engine, doesn't seem to work for us.
Okay. I think probably a longer discussion to take off and where the problems really exactly are. There might be to get this fixed if possible.